Hello folks, this is going to be the first of 3 videos that will cover the end of Unit 11 on equilibrium, and these 3 videos are going to highlight Le Chatelier's principle, where Le Chatelier's principle shows that if there's a change imposed on a system at equilibrium, the position of that equilibrium will shift in a direction in order to reduce that change. If you remember in our previous discussions on equilibrium in Unit 11, the equilibrium constant K is defined as a ratio of the products over the reactants. Since reactions want to be at equilibrium, they will shift in order to reestablish that ratio of products to reactants. You have to remember that equilibria are dynamic and not static. Therefore, the forward and reverse reactions are occurring at identical rates. The first thing we can look at is what happens if we add reactants or products to a system, or if we remove reactants or products. And the example that we will look at will be the reaction between PBr3 and Br2 to form PBr5. At the figure on the right, we can initially see here that the reaction is at equilibrium, where Q equals K, and at this point we are adding some PBr3 as a stress, and then we're going to investigate how this reaction will shift back in order to reestablish our equilibrium. If we consider our reaction quotient Q, we see that PBr3 is a reactant, so its initial partial pressure is going to be on the denominator. This is going to cause Q to be less than K, so the reaction will want to shift to the right to reestablish equilibrium. Therefore, we see that the amount of PBr5 increases slightly, and the amount of PBr3 and Br2, our 2 reactants, decreases slightly in order to reestablish the equilibrium. This next question, question number 11, asks you to figure out how Q is going to change, how that relates to K, in what direction the equilibrium will shift, and how the equilibrium concentrations of H2O and O2 will change when each of these stimulus are performed on this reaction. I want to give you a few minutes in order to work through this question, and I suggest you pause this video to try to fill in the blanks before you continue on. In the first row, we see that when we add O2, we are adding a product. This will increase the value of Q. Therefore, Q will now be greater than K, and the equilibrium will want to shift towards the reactant side in order to reestablish equilibrium. This will cause the concentration of H2O at equilibrium to increase, and that of O2 at equilibrium to decrease. If we add H2O now, we are now adding a reactant. This will cause the Q to decrease, therefore Q will be less than K, and the reaction will want to shift to the right in order to reestablish equilibrium. This will cause the equilibrium concentration of H2O to go down, and the equilibrium concentration of O2 to increase. If we remove H2S, we are now removing a product. This also decreases the value of Q. This will cause Q to be less than K. Again, the reaction will shift towards products, causing the equilibrium amount of H2O to decrease and that of O2 to increase. If we add H2S, the reverse process is happening. We are adding a product, so Q will increase. Q will now be greater than K, and so a reaction will shift to the left, increasing the value of H2O and decreasing the value of O2. Finally, the removal of sulfur will have absolutely no effect on equilibrium, and this is because sulfur is a solid, and pure solids and liquids do not appear in the expressions for equilibrium constants or the Q values. This concludes the first video for the Unit 11 on Le Chatelier's principle.